In this video, I'll be explaining what a Fourier series is, how to derive the coefficients of Fourier series, and as a bonus, we shall visualize the Fourier series. So here I have a graph of a square wave function. This function is a periodic function and has a period of 2 pi. So what a Fourier series is all about is trying to take any periodic function similar to this one and representing it as an infinite sum of sines and cosines. If we try to put this mathematically, it would look something like this. Now this is a better way to express the same equation. Now to solve for this equation, we would need to find the values of these coefficients. But before doing that, let us take a look at some important trigonometric formulas which will help us solve for the coefficients. The first formula is integrate from 0 to 2l an cos n pi x by l dx is equal to 0, where 2l is the period of the function. Note, we will not be deriving the formula in this video. Rather, I would encourage you to try it on your own. Moving on to the next one, integrate 0 to 2l an sin n pi x by l dx is equal to 0. The third one is integrate 0 to 2l an sin n1 pi x by l cos n2 pi x by l dx is equal to 0. The fourth one is integrate 0 to 2l an sin n1 pi x by l sin n2 pi x by l dx is equal to 0 if and only if n1 is not equal to n2, else the integral is equal to pi. The fifth one is integral 0 to 2l an cos n1 pi x by l cos n2 pi x by l dx is equal to 0 if and only if n1 is not equal to n2, else the integral is equal to pi. Okay, now that we are done with the formulas, let's move on to the derivation. We'll start with the derivation of a0. This is the equation for the Fourier series. Now integrate both sides from 0 to 2l. Now if you look closely, these two terms are similar to the formula that we encountered before, so they are equal to 0. Now solve for a. Okay, now let's derive the formula for an. This is the equation for the Fourier series. Now multiply both sides with cos n pi x by l. Now integrate both sides from 0 to 2l. Now if you notice, these two terms are similar to the formula that we encountered before, so they are equal to 0. Now in the remaining terms, all but one term is equal to 0. Now solve for an. Alright then, let's derive for bn. This is the equation of the Fourier series. Now multiply both sides by sin n pi x by l. Now integrate from 0 to 2l. You will notice that the two terms are similar to the formula that we came across earlier, so they are equal to 0. Now in the remaining terms, all but one is equal to 0. Now solve for bn. Now that we are done with the derivation, let's visualize the Fourier series. A Fourier series tries to approximate the shape of f of x. With each increase in term, the approximation gets better and better. So when the number of terms approaches infinity, the shape of the graph converges to f of x. Let's see it in action. We will try to approximate this square wave function. Now this is the first term in the Fourier series of this square wave. This is the second term, and so on. You can now start seeing the graph take the shape of the square wave. Finally, this is the Fourier series for this function. Let us try to derive the Fourier integral from the Fourier series. The Fourier series was meant to represent a periodic function over the real line, but the Fourier integral is used to represent a non-periodic function over the same line. F of x should be piecewise continuous and differentiable if we need to compute the Fourier integral. It should also be absolutely integrable on the x-axis. Now this is the equation for the Fourier series, and this is the formula for its coefficients. Now let us define some terms. W1 is equal to n pi by L, delta W is equal to pi by L, and 1 by L is equal to delta W by pi. Now replace the coefficients in the formula into the Fourier series and substitute for 1 by L. Now since it's a non-periodic function, the period of the function is infinity. Since L tends to infinity, delta W tends to 0. This term in the series converges to a finite value and it is equal to 0. This is in the form of Riemann sum, which is defined like this. So the sigma symbol is removed and replaced with an integration symbol. Now if you substitute these terms with AW and BW, you will finally get this equation, which is the Fourier integral formula.